Okay, cool. So I'm going to put that in for a sub 1. And what's the r? How do I find the r? Yes, now order matters. You can take any term and divide it by its previous term. You can't pick 960. Why not? Because it doesn't have a term before it, but you can pick any other term in that row. So let's say I picked 153.6. And then what should I divide it by? Can I divide it by anything? Have to divide it by the one right before it. And what do we get? Okay, so when I'm writing my explicit formula, what I write is a sub n. I'm going to write that just like I see it. In the spot where I see a sub 1, what am I going to write? 960 times r to the n minus 1. I'm going to write times 0.4 to the n minus 1 power. Now, just to show you that this works, okay, this is the first term. So if I wanted to find this term, I'd plug 1 in for n. What happens when you plug 1 in for n? You get 0. 960 times 0.4 to the 0 power. Do you guys remember 0.4 to the 0 is going to be 1? Gives me that. If I wanted to find the second term, then I'd plug 2 in for n. Plug 2 in for n. What's 2 minus 1? 1. So this is 960 times 0.4 to the first, and I get 384. So that's how that works. It generates terms by you plugging in the term number. All right, let's write down the recursive formula. For the recursive formula, we are going to write a sub 1 equals, and we are going to put the first term in that spot. So what should we write? 960, good. And then we're going to write a sub n equals a sub n minus 1. Notice that I'm not putting numbers in for n. They're just describing things. Times r. So I'm going to write times 0.4. Okay. Let's take a look at the next example. A virus reproduces by dividing into 2, and after a certain growth period, it divides into 2 again. As the virus continues to reproduce, it will continue to divide into 2. How many viruses will be in the system, starting with a single virus? Okay, so first of all, before it divides, there would be no divisions, correct? Okay, so and how many viruses did we start with? 1. Every time it divides into 2. So instead of 1 virus, now there are 2. It divides again, and now each of those divide into 2. So how many are there now? 4, good. And then it divides again. Now how many are there? 8. It divides again. 16. How many after the 5th division? 32. How many after the 6th division? Okay, so I'm going to put 64. What I'm going to try to show you is how this is something we did already, how it's exponential, and how we would now write it as a geometric sequence. Okay? So when we were doing exponential functions, our a was our initial value, or at time 0. What's the initial value here? 1. What is b? 2. I'm multiplying by 2. X is the number of divisions. Y is the number of viruses. Okay. If we were writing this as y equals a times b to the x, then we would write this. Y equals 1 times 2 to the x. We practiced doing that, right? Okay. An exponential function starts at the 0 spot. By the way, if b is 2, what would we consider the common ratio? Also 2. B and R are the same thing. Okay. All right, now, if I want to write this as a list of terms, we don't start at the 0th term. There's no such thing. We start at the first term. So here's a list of numbers. The first term is 2. The second term is 4. The third term is 8, and so on. So when we're writing an explicit formula, what's a sub 1? Which is what number? 2. So I would write a sub n equals 2. What's the common ratio? Times 2 to the n minus 1 power. I want to point out something to you. Because at first you say, well, those are two different things. They're not. It's just that when you're given a sequence of numbers, you're not going to be given the y-intercept. And so we need to write a formula that works for the first term. Okay? Let's go to 4. Would you guys do this for me? Punch in your calculator 1 times 2 to the 4th. And what do you get? 16. Now this should still work. Here, if I put a 4 in for n, what would the power be? If I put a 4 in for n here, what would the power be? 3. What's 2 times 2 to the third power? Still 16. They are equivalent equations, but one is just useful if you start at the first term. So that's why we have a kind of a little bit different formula. All right, let's do start next now. Oh, let's not. Let's just do recursive. What's a sub 1? 2. And then a sub n would be a sub n minus 1 times 2. Okay. Each year, the local country club sponsors a tennis tournament. Play starts with 128 participants. 128. During each round, half the players are eliminated. So basically everybody's playing somebody, and when they lose, they're done. So how many people are left after the first round? 64. And then after the second round, 32. 16. 8. Okay. Now, let's figure out an explicit formula. So we're not going to start at the start. We're going to start at the first term. The first term is 64. So our explicit formula would be a sub n equals 64. Can anybody tell me what the common ratio is? Yeah, it's not 2 because we're dividing by 2. 0.5 or 1/2 to the n minus 1 power. This kind of sounds like some kind of tournament that's going on right now. Does anybody know what tournament I'm talking about? Yeah, okay. So actually, the teams left after rounds in March Madness is also an exponential function, okay? So before any rounds of play have occurred, how many teams are there ignoring the play-in game? Anybody know? Who are my March Madness people? Okay, so there's 4 regions, and how many seeds in each region, Nate? 16 seeds in each region times 4 is 64. Okay, so the March Madness tournament started last Thursday with 64 teams. After the first round, this was the first round, okay? After the first round, how many teams are left? 32. After the second round, 16. That's where we're at right now, because we're at the Sweet 16, because all of these teams have played 2 games now. All right. So they now are in the third round, okay? There's 16 teams left. After the third round, there'll be 8 teams left. After the fourth round, there'll be 4 teams left. After the fifth round, there would be 2. And then there'd be 1. Okay, so how many rounds are there?
7.
Well, technically there's 6, because they wouldn't play a game with 1 versus 1 cell. All right. Okay.